Hello, this is Dr. Greg Goglin, Fair State University, and today we're going to go through database design. The first thing we want to cover is, what is a database? Well, a database is an organized collection of data. The key is that it is organized. Without the organization, the data may not be of use. So when you talk about a database, we're talking about organized data. Now, there are several different types of databases or database management systems. Relational databases like Oracle, Microsoft SQL Server, and DB2. Data warehousing databases. NoSQL databases. And there's many subtypes of NoSQL databases. MongoDB is a very popular one right now. There's a lot of document databases and graphic databases that are NoSQL databases. Object databases, and then there's many other kinds such as hierarchical and some of the older structures. Now, for our purposes, we're interested in relational databases. Relational databases are transaction databases where the relationships are defined by primary and foreign keys for the most part. Now, when we talk about transactional databases, those would be things where you're doing work such as purchasing something, where there's a lot of updating, inserting, deleting of records, things like that. The typical manufacturing databases, or a product database, or maybe a database that supports a cash register or something like that. Now, the data in a relational database is contained in tables, and they look a lot like an Excel spreadsheet. Now, Excel is not a database, but one table in a relational database looks kind of like a spreadsheet in Excel. So I'm going to go through a few different database designs. First, I'll go through a poor database design, and then we'll go through one that is much more ready for the real world, if you will. Now, this tool that I have is Microsoft Visio, and it is often used for database design, but it's basically used for a lot of different things, including making electrical diagrams and things like that. So it's a very much a multi-purpose piece of software. We're going to start out with the customer table. There's three tables in this database: customer, order, and product. Now, in the customer table, the primary key is the customer ID. Now, a primary key is what identifies a record in a table. It is not an index. An index is for speed. That's a different structure. Now, it is common that keys and indexes are operating on the same field, but they're not the same structure. Now, I have these little green boxes that talk about some of the challenges with this database design, and there's really three normal forms or three rules that you often go by to correctly design a database. You might read a database textbook and it talks about the 5 normal forms, or 7 or 9 or something like that. The reality is that if you go to 3 normal forms, you're probably in pretty good shape. And I was a lead DBA in a multi-billion-dollar organization for a number of years, and I never saw a situation that I can think of where 3 normal forms didn't handle every situation. So in the customer table, let's go through some of the challenges. First thing, customer name. Customer name is a violation of the first normal form, and the first normal form is there is no repeating groups in the data. Now you say, well, what's a repeating group? Well, in the customer name field, first name and last name would both end up being put into that field. Is it first name, last name? Is it going to be last name, comma, first name? What if there's a middle name? What if there's 2 last names, a hyphenated name? All different variations. And you can see that trying to put all of that into one field is going to cause some problems. So, first normal form, no repeating groups. We want the data to be atomic, or broke down into the individual structures. Another similar situation that is another kind of repeating group is where you see this phone number 1, phone number 2. The reason for that is to allow 1 or 2 phone numbers in the customer table. So you might have a home phone, a cell phone, a work phone, alternate phone, something like that. However, that's really not the best way to handle it. Sometimes it's a compromise in the design, but still it's something that raises a little bit of concern. Another problem in the customer table, right below that, the last field is called employer name. Now, employer name is not directly related to the primary key. The primary key is customer ID, and that's all the customer information. The employer name belongs in an employer table. Now, the employer name might be the name of the employer that the person works for, but again, it does not belong in the customer table. So that's a violation of the second normal form where the data doesn't depend on the key. If we go over to the order and product tables, you might notice the product name, and it's in dark or bold, is in both the order table and the product table. That is a violation of the third normal form, which is no redundant data. You don't want the same data in more than one location. It takes up extra space, and also it's possibility of not keeping it in sync. You might update the product name in one of the tables and forget to do it in another table. So you don't want to have product name in both of those tables. If we further focus on the order table, you can see that it is not directly tied to the customer. There's no customer ID, and that would be how you would define the relationship, would be the primary key. You would want to put in a customer ID into the order table in some fashion to tie the customer to the order. As this currently stands, you have no idea who placed the order. Now, if you look at the order table, you'll see a product ID, and that ties the product and order together. However, you can only order one product in a given order. So sometimes if you put some data into the tables, it makes it easier to see that. So visually, let's say it's order number 123, and we ordered product 16. Well, once you put 16 into the product ID in that order table, where are you going to put product ID 17? You can't without creating another order. So that's a problem with our current arrangement, and this is just a poor design. So let's move on to something that's a little bit more solid. And this is a normalized database structure. We'll again start with the customer table. And in the customer table, you can see with the kind of red colored boxes next to the tables some of the changes. Well, first of all, we made name atomic. We put in a last name and a first name. And that eliminates the challenge of, is it going to be last name, comma, first name, last name, that type of thing in the previous design. We also removed the employer name. If for some reason we wanted to tie the customer to an employer, we could put an employer ID into the customer table, and that would link us to the customer or to the employer database table. Now, phone number we split out, and we have the customer ID, area code, and phone number as all combination for a primary key. We took phone number and broke area code out of it, so we made that even more atomic. Now, customer ID, it depends on the way you're going to use the application. The customer ID can be part of the primary key, or it can be just another field that defines the relationship as a foreign key into the customer table. Depends on how you're going to use it. And a lot of times with design, you've got to ask questions of what are the advantages and disadvantages. This way very much locks a particular phone number to a customer. So could eliminate problems down the road with perhaps it'll at least flag duplicate phone numbers tied to different customers and things like that. let's move over to the order table and the products table. You can see in the order table, I took the product ID completely out of the order table. Now we want to be able to order many products in one order, and we also want to be able to have the same product be in many orders. So in other words, one order can have many products, and a product can be in many orders, is a many-to-many. A common way to allow this is to put a table in between, which I call a bridge table, and I usually name that the same as the two tables that it's between. So I use order and products and make that the order products table, and the key is the key of the two tables it's between. And when you have more than one field as part of the primary key, that is what we call a compound or a composite key. And the bridge table, which is the order products, resolves the many-to-many and allows you to have one order with many products, and one product can go into many orders. So let's go back and let's say it's order number 123. Well, if we go to the order products table, we put in order 123, and then the product ID is 16. And then if we want to put in the next product, we can go order 123, and the product ID is 117 or something like that. And that combination allows us to have many products into that particular order. One other thing that we did is we put the customer ID as a foreign key in the order table, and that ties the order to a particular customer. So we have a much stronger design than what we had previously. So we utilized the three normal forms. Let's go into SQL Server and take just a little bit deeper look and see what else we can find. What I did in SQL Server is define that customer table, and you can see customer ID has a little yellow icon next to it. That's the primary key. And when we define fields, we use what we call data types as to what kind of data goes into it. You know, numeric data, alphanumeric data, numbers, dates, and things like that. Well, in this particular instance, the customer ID is an integer. An integer is a range of values depending on which version of the DBMS you're using. It can be anything from, say, negative 2 billion to positive 2 billion or something like that. It's not a fixed number of digits or a fixed number of positions. You look to the third column there where it says allow nulls, and there are check boxes. Well, if you check the box, that means it would allow nulls. A null is no value. If you have a record in a table, you certainly need the key, so the key is required. Well, we do not want to have allow null in a key field, because that would mean you could enter a record without having a key, and then you have orphan data and dirty data and things like that. So we always require the value for the key, and usually good normalized databases require every field be filled in. However, that's more of a textbook thing than a practical use corporate thing, because as you maintain databases, you might add fields, and there might be historical data that you cannot go back and recapture to fill in. So a lot of times it's more of a go forward where you start capturing that data. If you look at the first name, we have a varchar 20. That's a variable character up to 20. So anything up to 20 characters will fit in there. If you try to put in 21, a character is going to be truncated. Last name is 30. Same thing. Anything up to 30. If we go down to zip, zip has a NCAR of 10, and that means it's a Unicode. Unicode is the double byte character set, and a double byte character set is something that will allow large numbers of alphabetical characters. So, for example, in Asia, you have alphabets that have over 50,000 different symbols. You could use this database if it had an NCAR, but you can't if it's just a regular char, because it's a single byte versus a double byte. You don't have as much space to put that in. Now, last thing to point out, the way I have these named, like customer ID, customer, it's a capital C and ID capital, or capital F for first, and that is an abbreviation, a capital N for name. Those are what we call double byte, or excuse me, camel case, zip. The reality is it's probably better to go zip code, or depending on how your abbreviations go, zip code. Camel case is where you capitalize the first character of each word in the name. So that is most of what I wanted to talk about. One last thing, let's look at what the data is like in a database table. We have 5 records, or 5 rows of data. You might hear a database textbook call it a tuple, refer to a row as a tuple. In all my years in corporate, I never heard any programmer or database administrator really talk about tuples. Everybody calls them rows or records. If you look at everything in the first name column, all 5 values, we call that a column. Okay, the first name column of data. And if you're looking at one particular cell, that's typically a field. So you got a record or a row, you have columns of data, and you have a field of data. So I hope that gives you some insight into database design, and we will look at some other things